like to do my presentation on you know smart smart caching system, boosting system speed and skill, right? So I like to tell you my objective or my aim to, because by end of this presentation, I hope you get a better understanding on why caching is important, how it works, the types of caching, then the strategies and the best practices you can get from caching. Let's start with sorry why smart caching is important. Why smart caching is important, right? Or why smart caching? Smart caching, one is also it helps to get access to data faster. Let me explain. Since was in the data, right, is stored on the memory, not in the not in other storage sources like the hard disk. um, Accessing it is very faster because since it's stored in the memory. And note, it's stored in the memory temporarily. Memory doesn't store permanent, it's stored in the memory temporarily. And it also supports simultaneous uses, which helps in a lot of throughput inside. And it's also very cost effective, very cost effective. Then let's talk about how caching works. So we're going to take an example. Let's say when an app, right, requests for a data, it first checks for the cache. If the data is already there, then it returns it immediately, which is called the cache the cache hit. But if the data is not, which is the cache miss, then the system is going to retrieve it from the source and save a copy of it for next time of future use. And the caching is very effective because of its locality principle. One. So the three locality principles I'm going to talk about here is one, temporal temporal locality. That one, it's what's the name? That one, it means recently used data is most likely to be accessed again or be used again sooner. Then the spatial locality. That one, it suggests that data which is near the current one will be used next time. Is most likely to be used next time. Data which is closer or near the current one is most likely to be used next time, which is, and we have the last one, which is the sequential locality. That one, data is accessed in a specific order, right? So that the system is able to preload upcoming data or values. Let's talk about the types of cache architecture. So we have different types of architecture. We have the CPU cache architecture. The CPU, before I even continue, the CPU, which is the brain of the computer, is just like that's what that's what is used to process data. That's the fastest that's the fastest way of accessing the data. Then it's also was located inside the processor. So then the second one is the application cache. That one, right, is mostly used to store results like the database. It's mostly used to store results like the database. Then we have the distributed cache. That one, it's shared across sorry, it's shared across many servers. And an example of it is the Redis. Then we have the CDN cache. Sorry, that one is stores web content closer to the user for faster delivery, so the user can get access to it faster. Then we have um the eviction and data sync, right? The eviction, since the cache has limited space, we need to set rules. We need to remove data. In order to remove the data, you need to set rules to remove the data. That's the eviction, right? So some policies or rules that you set to remove them is one, we have the LRU, which is the least frequent, was recently used. Then we also have the LFU, which is the least frequently used. Then we also have the FIFO, which is the FIFO. It's the first in, first out, right? Then another challenge is keeping the data consistently across multiple caches, right? So that is when the cache coherence comes in. So in the cache coherence, we mostly use invalid what's it invalid practices, like invalid practices to remove outmoded and outdated what's the name outdated entries when the main data and what's the name the main data what's the name changes. So we have the strategies is the last slide. Oh yeah, have strategies that we use, right? So the four common strategies that you can use are: one, the read through. The read through, that one, the cache fetches missing data. The cache fetches the missing data for you. Then we have the second one, which is the write through. All changes go to both the cache and the database. All the changes are go to the cache and the database. We have the write back. So you should know the difference between the write through and the write back. The write back, the data is written in the cache first, then it is synced to the database but later. So you should know the difference between the read through and the I say the read through, the write through and the the write back. You should also know the difference between the read through and the write through. But the two of them are different, they're not the same. And the last one, which is a cache, was on our side. That one mostly the application manually manages the cache update. For better results, you should mostly focus on caching data that is accessed often, right? Then secondly, you should set as priority time, which is the TT and TTL, to prevent outmoded data. Then also mostly monitor the performances of it. Then lastly, use was the proper invalidation. Yeah, well, here. Use proper invalidation tools like the Edge for faster global delivery. So I like to summarize my presentation, by telling you the I like to summarize my presentation by telling you, the importance of caching. That is, it helps improves speed. It also reduces cost, and also it helps what's the name in user throughput. A lot of users throughput, users using simultaneously at the same time also. Then also, in order to get the most out of caching, you should also know the best strategies and rules, the best strategies to use, which is regular monitoring it to check the performances of it. Thank you. Have a nice day.